paper is a trifold. It folds in thirds like this, okay? But a piecewise function. A piecewise function is a function made up of two or more functions with restrictions on the domain of each. And so you may want to pause and write all that down. But you end up with little pieces. This example is separated, but a lot of times you'll see in a minute when we do some examples, they'll be connected together. But if you can imagine, this is a line, and what we're doing is we're keeping this little part of it. And then this is a line, but we're only keeping this little part of it. And then this is a line, but we're just keeping this little part. So that makes a piecewise function. Okay. In order to evaluate a piecewise function, first look at the functions to decide which ones to use, and this is based on the x, and then evaluate only the one that we want. And so you may want to pause and write this down. Here is our examples. F of x equals 2x plus 6 if x is less than 2. It equals 10 if 2 is less than or equal to x or less than or equal to 6, and 3x minus 8 if x is greater than 6. So what we're looking at, we want to find these values. So what we do is we take these, remember this is f of x, so these are our x values here. And we're going to take that x and we're going to decide based on these equations which one do we use? Which one do we choose? Well, is 0 less than 2, between 2 and 6, or greater than 6? Well, 0 is less than 2, so that means that I'm going to use that one. So since 0 is less than 2, I'm going to use this function. So I'm going to put x into, or put 0 into x here. Oops. So we have 2 times 0 plus 6. 0 plus 6 is 6. Okay. F of 7. F of 7. Well, 7 is greater than 6. 7 is greater than 6. So that means I'm going to use this function. So I'm going to do 3 times 7 minus 8. And 3 times 7 minus 8 is 13. Next, f of 2. F of 2. Well, 2, there's a 2 here and here, but this is less than 2, so it's not including 2. This one equals 2, so we're going to use this one. There's no x to replace there, so this value is simply 10. Okay, f of negative 4. F of negative 4, the negative 4 is our x. It is less than 2, so we're going to use this equation. So 2 times negative 4 plus 6, so negative 8 plus 6 is negative 2. F of 1. 1 is also less than 2. 1 is also less than 2, so we're going to use that same one again. 2 times 1 plus 6. 6 plus 2 is 8. The next one, f of 6. F of 6 falls here. It is equal to 6, so it falls between this range, so it's simply 10. There's no x to replace. And then f of 12. 12 is larger than 6, so we're going to use this equation for the 12. So 3 times 12 minus 8. 3 times 12 minus 8 is 28. So if you're just asked to evaluate, that's what you're going to do. You just have to pick which equation to use based on your restrictions here. Okay? Now, next is graphing. When we graph each function lightly with a pencil, and remember we talked about on the beginning here, we talked about we're just using little pieces of your function. So you're going to graph the whole thing, and then using the restrictions, erase what you don't need and darken what you are keeping. Okay? So again, you may want to pause and write that down. This one won't all fit unless we go by twos. So I went by twos here. This is the same one that we just did over here with our evaluating. The first one, 2x plus 6. So this means we're going to graph the line y equals 2x plus 6. So that means I go to 6 on my x-axis, and I go up 2, right 1. And even though we're going by twos, you can still do 2 boxes. And I didn't do a pencil. Oops. But you want to do this to begin with a pencil. So here's our line. But we only want if x is less than 2. Well, here is our x is 2 here. So here's our 2. So we only want this part, and we want an open circle. Okay, so that means we would erase this part of our line. And you won't be able to see this because I put my dot in marker. But this dot is supposed to be an open circle. And then we're going to keep this part of the line. Okay, so remember, this is supposed to be an open circle. It won't matter here in a minute, but for now, that's supposed to be an open circle. Then the next one is y equals 10. So we're going to graph y equals 10. Well, the line y equals 10 is simply a horizontal line through the y-axis at 10. So this would be the line y equals 10. But we only want to keep from 2 to 6, and 2 and 6 here would be closed circles. So here is an x value of 2 and our x value of 6, so we're going to keep from here to here. So 2 to 6, and those are closed circles, and then we just don't need the rest of it. So it doesn't really matter that we accidentally didn't make that open a minute ago. And then the last one, 3x minus 8, if x is greater than 6. So y equals 3x minus 8. Well, that line, we would go to negative 8. 2, 4, 6, 8. And our slope is 3. So again, we can just use our boxes. We're going to go up 3, right 1. Up 3, right 1. And we get this line. Okay, but we only want it if x is greater than 6, so we only want this part of the line. So we can do away with this. And once you get used to doing these, you can actually kind of skip and only graph the part you need. So then you get that. So that is your piecewise function. Now this one happens to all be connected together. Okay. Another way that you can do this is you could say, well, if x is less than 2, let me make a table, and I could go 2, 1, 0, and know that this is going to be an open circle, negative 1. And then I could put those values in here, and I would get 10, and 2 times 1 is 2, plus 6 is 8, 0 plus 6 is 6, negative 2 plus 6 is 4, and then I could plot those points, 2, 10, 1, 2, 10, 1, 8, 0, 6, negative 1, 4, and you could make tables for each one of these to graph them. It's a little bit longer, but if you have trouble graphing, that's one way you can do it. Okay. The next example, g of x equals 2x plus 4 if x is less than 0, and 4x minus 5 if x is greater than or equal to 0. Now again, this one, f of x is, g of x is the same as f of x, which is the same as y. So think of this as y equals 2x plus 4 if x is less than 0. So I'm going to go to positive 4, put a dot. I'm going to go up 2, right 1, up 2, right 1, down 2, left 1, and so on. Now this is what I was saying, you could just kind of, we want x is less than 0. Here is x is 0, so we only want everything on this side. We don't want over here, so I just don't even need to do that part. And I'm going to put an open circle here, and then go down here. And then for my second line, y equals 4x minus 5 if x is greater than or equal to 0. So I'm going to go to negative 5, and then I'm going to go up 4, right 1, up 4, right 1. And then I don't even have to go down here because I'm only going greater than 0, so I don't need this part. So I'm going to have this time a closed circle here. And you really should use a ruler or something straight to make nice straight lines. So that's our piecewise function. And notice it is a function, so as you go across, you should never touch 2 points at one time. They'll never overlap. You won't have a line here and then a line over top of it somewhere. Okay? And then next, h of x equals 5 if x is less than or equal to negative 3. This one is a really easy graph. The first one, y equals 5, just means we go to 5 on the y-axis, and we go straight across. And we want if x is less than or equal to negative 3. So at negative 3, we're going to have a closed circle and less than, so we don't want this part. So we have a closed circle here, less than. 2/3 x, that one looks a little different, but it's really easy. There is no plus here, so the y-intercept is 0, so we start at 0. And our slope is 2/3, so we're going to go up 2, right 3, up 2, right 3, up 2, right 3, down to left 3, and again we could stop here because we know we don't want any of this part of that line. So I can stop there, and that needs to be an open circle because it's just greater than. And then we're going here. So think about your x's. Here's negative 3. All of these x's are less than negative 3, so we want that part of the line for the less than. All of these x's are greater than negative 3, so we want this part of the line for that one. Okay, so that's graphing piecewise functions. The last part is using them and interpreting what they mean. This is cell phone. You could read that, but C of 30 means what is the cost of talking for 30 minutes. So C of 30, if we come up here, between 0 and 60, the cost of 30 is going to be 20. And also 40 is between 0 and 60, so the cost of 40 is 20. So what these mean are that you can talk for 20 minutes or 30 minutes, costs $20. And this one would be 40 minutes, costs $20. The 180, you're going to put those both into this formula because both of those are greater than 60. So the cost of 100, plug those in and you should get 36. So that means 100 minutes costs $36. Aren't you glad cell phones don't work this way anymore? And then the last one, C of 80, should be 28. So that means talking for 80 minutes costs $28. Okay, so I hope this helps. Fold these and glue them in your notebook, and hope you have a great day.